Okay, we have, it's 5:22. We have, this is video number 98, and you see that I've worked out the first 6 problems on your assignment here. And we're not going to spend a long time on this, but we will, just showing you I have everything there. And I'm going to move left to right and take care of the work for you here. And we'll start with the top one, and I'll move the angle of the camera along as I go. And let's make sure we keep the big picture in mind. When I talk about 63 squared, I'm thinking of 2 numbers, and I'm turning A into 60, and I'm turning B into 3, and then I'm just thinking A plus B squared, and I'm using A squared plus B squared plus 2AB that we verified many times. So I sort of turned 63 into 2 different numbers with 2 variables. You should really be understanding what I just did there. And then when I do the rest of it, I take advantage of the fact that we know how to do FOIL now, and we see what an important technique it is and how it can help us with other numbers. So you see that 60 squared is 3,600, so that makes it easy to calculate. And there's 3 squared coming out to 9, and then 60 times 3 doubled is, so 60 times 3 is 180, doubled is 360. I add them together and I get 3,969. Shouldn't make fun of the number. It's a perfect square, and I want to verify that because I'm going to put the hat on it. And you all, I wish the class were in front of me, but moving this over just a little bit, you should expect when you put the square root button in, and you put 3969 being a perfect square underneath, that you get 63. So the weaker student should understand that when I added everything up, then I put the hat on it, and I went in a big circle. So I found 63 squared using this new math. And so with the other one, it makes more sense since 89 is closer to 90 to use that. And here it would be A minus B, right? Again, I'm repeating to help. And what's A? A is 90. And what's B? B is 1 or -1, depending on the way you look at it. There it is down there, okay? Doing the math, all right? And so that I go on, and you can follow the math I did up here, where I got 8,100, and there's the 1, there's the minus 180. How did I get minus 80? 180, 90 times 1. It's I had to subtract because it was easier to get to 89. And then if I put the hat on, 7921, another perfect square. Interesting to notice these numbers that happen to be perfect squares. I'll pop out with 89. And then I go over to a bigger number. We're not really interested in bigger numbers. I've mentioned that a number of times. But we're using a bigger number anyway, just to show students that it works. So 302. I break it up into 2 pieces. Add the zeros, right? 4 zeros, 3 times 3. That's why we like perfect squares. They're the nice ones. Then I add 4. We're here good. And then I add 1,200. How did I get 1,200? 300 times 2 times 2. Should be clear now. If I put the hat over 91204, there's another one over here, just pointing it out. Another perfect square. Interesting, these kind of perfect square guys. And then I go on to the second one, the second class of, and I want to erase these guys on the top. Okay, so I go on to the second class of just number problems, right? Again, we're applying the math that we learned abstractly with A's and B's, C's and D's. We'll talk about that as well. And erasing all this so that we're in good shape. Going ahead here, dry enough and white enough. So here we go. And we're now doing the second set of problems. And here's the idea of what's 61 times 59. Of course you put it on a calculator. Of course you could do it the standard way. But here's just another way. And what are we talking about this time? We're talking about a squared minus b squared, where a and b are any numbers, equals a minus b, a plus b, a minus b, a plus b in any order. So in this case, we're letting a equal 60, and we're letting b equal 1. So b flips from 1 to -1. And so when I write that out, you see it right here, going left to right. And the beauty of this, as we've said so many times, is that the middle term disappears. So I'm just using this format, this configuration that I called it, to do these numbers here. So it's true enough that 60 plus 1 is equivalent to 61, 60 minus 1 is equivalent to 59, but I can do the work really fast now because of the middle terms go away. 60 times 60, we see it right there. We move quickly. 1 times 1, but a negative times a positive, minus 1, and you can check on your calculator, there's the correct answer. So that's a trick they want you to know. I don't know if it's a trick, it's a nice way of looking at numbers, make you more numerically literate as you move along on your mathematical career. Same idea with 27 and 33 that you see over here. There's the -3, there's the +3, and the calculation is instantaneous, as you can see. Okay, I'm moving over here. All right, and finally, the last one like this, if you get it, it doesn't. This is just to prove that the big numbers, you can do this the same way. And there again, remember to add your 2's correctly or use scientific notation, and then you get 40,000 minus 4, and then there's the number, done really quickly, very efficiently. And you might even add that in this last case, there's the number, there's the answer. This method beats doing it the old-fashioned way. Of course, nothing beats the calculator, right? Okay, so there you are with those first 6 numbers. And now I'll turn our attention to the last ones. And this is just a new configuration, not a new configuration, it's just the configuration we did in another context to show you how you can work with these numbers. Okay, and I wrote some of them up there. Typically speaking, your average high school kid, once they get one, they get them all. A lot of them are shrugging their shoulders, saying, well, I could do this on a calculator. True enough, but math is not all about calculators and doing things on calculators, as you probably noticed already. So here we go, and we're asked to calculate real quick. They say mental math. I don't know about that. But we're asked to calculate really quick what this equals. So it's pretty obvious what I'm going to do. It's obviously a squared minus b squared, any old numbers, okay? And because this is a minus b in any order, I had to keep saying that because kids get confused. There we go. And so let's see what we got here. So we have 38 minus 32, because I said a equals 38 and b equals 32, times 38 plus 32. So in this case, you certainly don't want to FOIL. That's a lot of work. But what's 38 minus 32? Well, that equals 6, right? And what's 38 plus 32? That's 70. So I did. Okay, and I'll move that over there so you can see. Okay. Left to right. And this works, this trick, so to speak, this idea that the Regents wants you to know when the numbers are kind of close to each other. So that's why when I do the second one, 76 minus 73 squared, looks like such an imposing problem when you first see it. But it's really just nothing when we write it out. This is what we really want. I get 3. I guess it would be more work, but completely doable. Completely doable. And I don't know what this is, 14 plus 9, so this would be 149. And so then I'd multiply 149 times 3. Maybe we should have done that, but beforehand, right? And then we come up with 4. What is that? Let's see, 27, carry the 4, so I come up with 447. But if there's a mistake there, you'll forgive me. The idea should be super clear. Okay, we're coming up on 11 minutes, and again, I'll do the last one so everything was done. So you'd be expected to figure these things out now. Let's look at the last one here. Oh my God, 120 squared minus 118 squared. So here, when I do everything here, easily done by hand, but maybe in this particular lecture, we'll just add them together. But notice I kept them close here because when I do parenthetically, I'll move it over in a second so you can see what I did, because I'm doing this. So I come up with 2 times 8, 238. And then 238. So I'll show you what I did. Because I didn't work on before. I come up with 476. Okay. And without checking the calculator, I'll put that over there. And I'm moving everything over so you can see it. And there we go. There's 2. And then I added together and got 238. I doubled that and came up with 476 here. 447 here. And 420 here, without using the calculator to check, because I wanted to get this all into one video. And so you guys can double check me there, and now you've seen the basic principles of what happens when I plug in this double variable idea. I can do things with numbers that I didn't think I could do before. And in some cases, as we've seen this morning, it's even better than doing it by hand the old-fashioned way. However, notice when the numbers got a little bigger, like what's 120 plus 118, when they say mental math, I don't know, most of us would probably pick up a pencil or something like that, or a calculator. You know, we're reasonable people. So there's the math. There's assignment 37. I'm going to give you time to do 38 because I'm going to do some problems, square problems. I was asked about that via email. I'm going to do that in a lesson today. So let's move on.